Yeah, we are all set. The stage is yours.
Hello, everybody. Can you hear me?
Yes.
Yeah.
Great. I see nods. So first of all, thank you, Kostya, for inviting me to give this to give this lecture and this meetup. I'm sure in this community, everybody already has heard about the course that YData is leading of data science, and I do guest lectures there once in a while, and it's always a pleasure to see the work that you're doing for this community and the impact that this course has on our ecosystem. So let me share my screen. Do you see the first slide now?
Yep.
Great, just a second. Okay, so the topic today is very close to my heart. Wait, just one more minute. I wanna set up the Zoom so that I can see as many faces as possible. By the way, thank you everybody who has their camera on. That helps a lot with connecting. Okay, so the topic that we'll talk about today is very close to my heart. As Kostya said, nobody really teaches us how to work with academic papers in university or after it. And in many ways, the first part of this lecture, how to work with academic papers 101, is the lecture that I would want to get 10 years ago. And this and the problems, I've felt them so badly in my life, in my career working with academic papers, that at some point I actually went ahead and got some friends together, and we built in our spare time a tool that is given for free to any researcher who wants to use it, and helps them discover academic papers. So on our weekends for the last, as Kostya said, year and a half, we built a tool, and it actually launched 6 months ago with great success. And today I'll demo it. And in the third part, I want to spark, like to light your imagination. I want to give you a vision that I've had for many years of what a platform we can have in the future, the next generation platform for working with academic papers. And there I hope to simply spark a discussion. So let's start. I'll give a brief introduction of myself. So I come from a background of electrical engineering and physics. And in most of my career, I dealt with computer vision, both classical and the new age, deep learning technologies. And what you can see on the right here is already links to some Medium posts that I wrote while working as an engineer, and then a team leader, and then a group leader. These are example of blog posts where I sort of distill knowledge that I have from working on a certain academic niche, like video object segmentation, and try to share this knowledge so others can also benefit from it. And I was surprised with how many readers apparently there were for these sorts of very niche articles. I mean, we're talking about a subject of deep learning for video, and there was like 30,000 readers to these blog posts, each one. And that made me realize that there is a huge demand for this sharing of knowledge. And at some point, I started researching this idea with some friends of, I can say it in one simple way. What if we had something like IMDb is for movies, but for academic papers? What if we had the equivalent of Goodreads for books for academic papers? And this led me into like months of thinking in my spare time and researching and finding every possible tool that already exists for academic papers. And the answer was that this doesn't exist, and I'm not sure why. I have a lot of hints and ideas, and we thought to do it. But the deeper we thought about it, realized it's a huge, huge project. This is like years of work and lots of risk taking, and it's about building a community. And so it was a bit too big for us at the time. And instead, we simply, me and my friends, I'll introduce them soon, we built one feature from this big grand idea. And this one feature turned out to be the what today is the tool Connected Papers, which is a unique tool. It's a tool that helps you visually discover new research or research that is new to you. Okay. And now I would like to learn a little bit about who is here today. And I'll activate a poll. Because I think there is a very, can you see the poll now? Yeah, it's in progress. So I think there is a very like strong variety here in the people who are attending. I'm assuming some people are juniors and haven't worked a lot with academic papers, and others have published tens of articles. And so at least in the first part, we'll learn very little new things. And this will help me calibrate how to spend my time during the lecture. Kostya, this is so much more high-tech than raising hands in the class.
Indeed.
I'm gonna wait 10 or 15 more seconds.
Eddie?
Yeah.
The third question is like missing words. It's not written, fully written.
How many academic papers have you published? What's missing?
It says, how many academic papers have you? And that's it.
I think there's something with your window because I see the word published at the end. The third question is, how many academic papers have you published?
Thanks.
Okay, I think that's enough. I'll do end polling. And I'll share results. Right, Kostya? It doesn't erase it or something?
Yeah, that's sure.
Okay, so now everybody can see. So how many papers do you read monthly? We see a majority for 1 to 5. That's actually a lot. That means everybody here, or at least most people here, work with papers in their daily work. And some people are prolific readers with over 10 papers a month. How many academic papers have you summarized in your life? Over 10 is the majority. So we definitely have here today an audience that works with papers. That's great. How many academic papers have you published? So, okay, so I see that the majority here are readers, not writers. So majority reads, but also hasn't published a paper. And still about 37% published. Have you used connected papers? Okay, so about 80% haven't used, which means that the demo at the second part will be important, and I will be careful with it. I mean, I won't have assumptions about you using it before. Finally, about the wide data meetups, Kostya, that's for you.
Yeah.
Okay, so thank you for participating. This definitely calibrates how I will spend the time now. Okay, so let's get some obvious things out of the way. And the next few slides will be for more juniors, more people who don't have a lot of experience working with the papers, but bear with me, I'm getting to more advanced topics later. So the obvious thing, papers are hard to read. And the reason for that is that they are not optimized for reading. They're not optimized for you understanding. They're optimized mostly for getting accepted into a publication or a journal or a conference. And that has its own whole ecosystem of requirements, which is not being as clear as possible. And as the comic says, if we make it too easy to read, everyone can do it also. And like one basic thing to understand about reading a paper is that it's not like reading a book. It's not a linear process where we just go page after page after page. A paper has a certain anatomy with the title, authors, abstract, introduction, and so on. Most of you know this, of course. And the way we go through this is not linear. We jump around. We start with the abstract, we move to the conclusion, we jump to the figures, And after we engage with it a little bit, we know whether we want to engage deeper and how to engage. And the second obvious thing is that finding papers and managing papers, especially today, and especially in the areas of data science. And by the way, this lecture can be applied to all sciences, but it will be biased towards data sciences, both because of the meetup that we're in and my own experience. So it's overwhelming. There's just an overflow of information. There's too many papers coming out all the time, and it's really, really hard to keep track. There's a story I wasn't sure if to tell, but I always go for embarrassing myself as much as possible. But for years, when I was sitting in the bathroom, I don't know what everybody else is doing while they're in the bathroom, but while I'm in the bathroom, I was reading archive. I was going over the titles and abstracts of every paper that came out in the computer vision and pattern recognition and section, and that worked for me around 2016, 2017, and then there was just an explosion. There was not in the bathroom and in the paper world, there was no way to keep track. And so I had to find better methods to distill the papers that I want to find. So in simple terms, there's too many papers, not all of them are relevant, not all of them are good, and how do we keep up? And the comic on the right basically is a projection of NIPS registrations, new RIPS, I should say. It's the biggest NLP conference. And as you can see, by 2050, the projection is that we'll have more people registering to the conference than exist. Yeah. So now I want to get to the meat of this part. And that is, I want to give you a mental model that I have of approaching academic papers and how to work with them. And it's very simple. It starts with discovery, then goes to skimming, then goes to reading, and finally to owning. And now I'll explain them. So discovery is something that takes between days and weeks, I think. It's basically when you want to enter a new field or learn a field that you already know better, and you're starting your search. And it starts usually with Google, but there's a lot of things that we do to get a long list of papers that may be relevant to our research or to our work. And for those who haven't worked with papers, I'll actually explain some of the methods that I wrote here. Keyword searching is obvious, that's Google. But alerts, today, both in Google Scholar and in Semantic Scholar, which I will introduce later, you can set up alerts for your favorite authors or for certain papers, and then you will get an email when they have been cited or when the authors release something new. Social groups is basically your group at work or your Slack group with which you're sharing papers, or friends in your lab in the university. That's a great resource for finding new good things. Crawling references, which that is my favorite activity. Literally going over references of one paper that you like one by one and trying to identify which one of them can also be relevant to me. This exact experience is what made us create Connected Papers. Blogs, of course, newsletters. That's actually the thing that I did after reading all of archive in the bathroom, is finding like 3 or 4 newsletters in the subtopics that I'm interested in, and they curate papers for me weekly. Now, actually, before I go to this, the part of discovery is super important, at least in my experience with my teams in industry. Starting with the right paper, you never solve a problem in a vacuum. So you always try to find the most similar problem that was solved and hope that it has some kind of open source code. And finding the right one is critical. It can save you weeks or months of work. So this part is, in my opinion, is the most underrated part. And many researchers rush to working with some paper instead of investing enough time to make sure that they properly covered and understand their field. Skimming. So the goal of skimming is basically to have awareness that this paper exists, that later someday, if you need it, you can remember, yeah, something like this. I read something like this. and to create a short list of papers for the next stage. And how do we do this? This is usually something that takes 5 minutes. You look at the abstract, you take a look at the figures. I think, especially in our field, the figures are probably the most informative part of the paper. You look at the results, and maybe if you see results which are state of the art, you know this is something that you're interested in, because every paper, of course, writes that they are the state of the art. Every paper claims to be the best at everything, or at least at something. But results, they speak for themselves, even though that also is in question sometimes. You look at the metadata of the paper, like, do you recognize the authors? Are they from Google, or are they from somewhere else? Popularity basically means citation count, and external resources. A lot of time before I actually read a paper, I try to find a video explaining it in 2 minutes, or a blog talking about it, and that saves me a lot of time deciding whether it's relevant to me. Reading is something that takes hours. Actually, it depends a lot on how familiar you are with this topic, but usually it takes hours. And the result is that you actually understand the paper to the point that you can explain it to your friends or to a class. And that's the hard nonlinear process that we talked about. I actually have a full slide about it, but I think it sort of is not necessary now. But when you do the full reading, you actually invest time in the introduction and then the conclusion, and then you go to the main body with all the equations, and you start, your war with them. And after you're done, I really recommend to reread for getting a full picture. And finally, owning. This is the one I think is not obvious. Owning is a process that could take days to weeks. And I measure it this way. Are you able to actually reproduce the paper? Not just explain to something what was done inside, but if I were to take the paper away from you, would you be able to get the results yourself? Would you be able to write the code? Would you be able to get the whatever research results there are? And another way to identify that you are now at the stage of owning a paper, that it's like your own at this point, is when you start finding mistakes and when you can improve things in it. And to get to this stage of owning, there is only one way, and that is hard work. You need to actually research this topic. You need to actually work with the code. You need to try to improve it. And that's where at some point you start owning it, and you can find the places to improve and mistakes and so on. Now we'll give, this is like a quick version of the working with papers lecture that I gave in YData. So I'll be quick. Some tools. First one is Google. Reference managers. I still know a lot of professors and people who are reading hundreds of papers a year who do not use this and are keeping papers and folders on their computer. So to those who are not familiar, reference managers are a great way. Maybe I'll just, this is a screenshot of Zotero, which is one of them. This is simply a way to have a library of and manage all the references and all the papers that you have read, want to read. You can arrange them in different ways. You can share lists with friends. And without this, I don't know how it's possible to work with a big amount of papers. Some other tools. So Semantic Scholar is probably the most useful tool that is also unfamiliar. It's sort of like Google Scholar. And I think it's better at this point. It has maybe less coverage, but it's actively being developed. Maybe I can open it and yeah. So basically, for every paper, you get this this page with an abstract. Usually, they're also highlighting here some methods or something like this. Maybe let's try a less new paper. Yeah, so you can see, for example, here they're highlighting a key method, and they have a way of identifying influential citations. And below, you can see there's a lot of supplementary material like code, which comes from Papers with Code, with whom they have an integration. figures, which you can see without actually opening the PDF, which is super useful for skimming, in my opinion, and a digital link to all citations. I think this should be the default link that you're sending when you're sending a paper, not like Archive or Google Scholar. I think this should be like the semantic scholar URLs are what I am today saving in my personal notes. Oh, I actually put a screenshot here, so didn't have to go to the website. Other tools. Archive Vanity is a great way to read papers online instead of in PDFs. If you don't like squinting at PDFs, then Archive Vanity sort of unrolls it into a nice web view. Papers with code at this point needs no introduction, but the first time I did this lecture, it did. And that's the default place to go when you want to connect a paper with a repository when you're working in data science and machine learning specifically. And today they're doing much more things that they did in the beginning. They have a tracking of state of the art. They have division to methods, and now they're starting to do some work to support reproducibility. That's a great resource. They've been recently acquired by Facebook and are sort of independent there. So I think they're going to be a resource that's going to just keep improving. And Open Review is a great example for for how a peer review process should look like. It's a place you can go for some conferences like ICLR, for example, where you can actually see reviews, the official reviews that papers are getting in conferences and the discussion that follows. And you can also see unofficial reviews of papers. And this already ties in with the third part of the lecture about having a social platform. For authors here, and there were many of you, so one tool that I think is great is Overleaf. Overleaf is like sort of like Google Docs for writing papers and in LaTeX together. Authoria is more of a next generation editor, which is WYSIWYG, what you see is what you get. You don't write LaTeX, you can actually, it feels like writing in Word, and you can embed data. So if there is graphs or something, people can actually see the data behind them. And CodeOcean is a platform which sort of exists for empowering reproducibility in your work. So you can upload code that is related to your paper to this platform, and they have their own jargon. They create capsules which other people can download, and the environment will simply run on their machines. Okay, and now I can add our tool, Connected Papers, which when we go back to this whole mental model, fits very neatly into discovery and a little bit into skimming. And now I'll present it. Okay, so just to make sure, Kostya, can everybody see Connected Papers now? Can everybody see my screen?
Yes, we can see it.
Good, good. I see the nods. Okay, so Connected Papers is what we did in our spare time to solve a problem that we personally had. And at some point, the students of YData were our beta testers, and we released the project 6 months ago. And since then, almost 500,000 people have used it. And I'll try to give a demo of it. So this website allows you to explore Connected Papers in a visual graph. And it's the only tool that I know that's actually, in my opinion, useful that allows visual exploration, visual navigation of paper space. So if we look, for example, if we search for a paper, this has an autocomplete. So deep fruits, a fruit detection system using deep neural networks. And we get a graph. Now, let me explain what you see. Each node in this graph is a paper. The size of the node is the popularity or the amount of citations that it got. The color of the node is the date of publication. So newer nodes will be darker newer papers will be darker and older papers will be lighter. But the most interesting and important thing about this graph is the XY position. How do we actually determine the position of the nodes in the graph? And this is built on our concept of similarity. So nodes that are close to each other are more similar. Papers that are closer are more similar. And our similarity metric is important. Basically, we use the following idea. We use the overlap of citations and references for papers. So if we have two papers and they have a lot of identical citations and references, that gives us a lot of information. That's a strong indication that they are dealing with the same topic. Okay, that's a very simplified explanation of the metric, but in the end, what you get is similar papers. And let me give you maybe one example which can illustrate why this is useful and unique. So imagine you have two groups who are releasing a very similar papers on the same day. One is in the United States, the other is in China. And they're not aware of each other. They've released on the same day, so they can't possibly cite each other. And also their language is different. They're writing about the same topic, but one is American, one is Chinese, and maybe they're using different keywords. So in our graph, these papers should be very, very close because they're probably citing similar works. And because as time moves on, similar works are like the same works are citing them. So with the movement of time, they're actually going to get closer and closer in our graphs. And a very new feature that we have, by the way, we added it last week, is showing versions of our graphs. So for example, this graph used to look differently before. Okay, while it's building, I'll simply, I think it's stuck. Okay, while it's building, I'll go back to this one. So yeah, so now explain similarity. And the way we build a graph is basically once we get your initial input of one paper, we analyze on an order of 50,000 papers. Sometimes it can be much more. And we choose about 40 or so papers which are most similar to your input, and we build you this graph. Now we also have a list on the left, so you can navigate it with the list if it's more useful, and you can expand the list and actually see some details about the papers in the graph. And I think a nice feature here is that you get an immediate preview of each paper on the right side. So whenever you select a paper, whether it's in the list or in the graph itself, you can see, even without selecting, just by mousing over, you can see the metadata about it, the abstract, and some useful links, for example, to PubMed, to Google Scholar, to the publisher page, to Semantic Scholar. A lot of the time, you'll see a link here to Papers with Code, with whom we've lately integrated, or to the PDF itself. Now, two more features, or maybe we'll call it one more feature, which is very important to talk about, is the prior works. It's the big button here, and the derivative works. So the prior works and the derivative works, let's talk about the prior works first. It represents papers which are ancestors of this origin paper, of the input paper that you've put. Now, they're not direct ancestors in the sense that they simply are cited by it, but they are actually ancestors commonly of the group, of the whole graph that you're seeing. In other words, if many of these papers in the graph are citing the same ancestors, then they will appear here in the prior works, and that actually creates a very robust list. We can actually click like on one of the papers in the prior works, and we can see all the papers which are now colored in this color, which are citing it. And the derivative works is the opposite. It's basically works that are citing many works in the graph. And what you get usually when you do this is either very new state-of-the-art works which are relevant to what you're searching for. So imagine you had a paper from 2016 and you really like it, and you're asking yourself, is there something newer, more relevant to me with better results? Usually the derivative works will point you in the right direction. And the other sort of papers that you'll find here are reviews. So for example, the second one here is a review. And the reason you'll find reviews here is that they are, of course, citing many of the papers in the graph. And again, if we go back to the graph, we can see all the papers which are being cited in this review. Okay, now I want to maybe sharpen a little bit the understanding of what our similarity metric is doing. And by the way, everything I am explaining can be read here, and how to read the graph, and you can go to learn more, and it explains a little more. But here's one. Let's even look at this example. So the paper we're looking at is Deep Fruits, a fruit detection system using deep neural networks. Okay, and we can see here there sort of is created a cluster. And when we look at the papers in the cluster, it's names like RFCN, object detection via region-based fully convolutional networks, or you only look once, YOLO, which is famous, or things like reverse. Basically, without reading all the titles, this cluster here shows you classical object detection deep learning papers. And if we start looking at the top part of this graph, then we'll see things which have small fruit detection in them, visual detection of occluded crops, classification with orchard metadata. In other words, the top part here is basically works which are related to agriculture. It's a cluster of how deep learning can be used in agriculture. And that's what you get. You get this clustering. And sometimes it's very, very obvious. You see a paper which is in the sort of junction of several branches of science. Now, the way that we recommend to use this tool is to start, of course, with one paper that is interesting to you, and search for it, and then build a graph and look at this list and look at the graph, and this will give you an initial list of papers that could be also interesting for you. And then especially once you find some paper that is super interesting to you, you can click here on this button, build a graph, which automatically takes you to a next graph, which is created from this paper. And we like to say here, now you're thinking with portals. And basically you can explore paper space, and that's the new word, paper space, by moving from graph to graph to graph. Usually in 2 hops, you'll get very specific results relative to what you were looking for. Yeah, so what basically do people use this website for? They use it to get a visual overview of a new academic field. They use it to reduce fear of missing out, to make sure that you haven't missed an important papers. A lot of time before this tool existed, I had this fear that I'm missing some very important paper that came out in this field, and there's no way to confirm that it's not the case. And when you see it structured visually, you sort of know, yep, everything here is familiar. Create bibliography to your thesis, and discover the most relevant prior and derivative works. Yeah, let me see in my notes if I maybe should talk about something else. Maybe one trick. So take a look. You see also there are connecting lines here in the graph, and they're here for a reason. The connecting lines that you see between papers are for a very similar purpose to the location of the papers. They also represent similarity. So papers which are similar to each other, nodes that are similar to each other, will have strong connecting lines, and nodes that are not will have very weak connecting lines. So why do we have both of them? The reason for that is that the similarity is happening in n-dimensional space. And what you're seeing here is a projection on 2-dimensional space of this similarity, which basically means that we're not perfect, that there can be instances where papers which are very similar will not be very close together in the graph. And this, the lines are helping understand that. And one nice thing that comes out is that thanks to the existence of the lines, it's much easier to identify clusters. So for example, if you would look at this graph without lines, it would be much harder to realize that there is a bottom cluster here and a top cluster here. Yeah. Okay. So I think that's enough for the demo. And after a few more slides, I'll let people ask questions before we move to the next part. So this is you can see the slides again now, right? Yeah, people are nodding. Thank you. Okay, so this is the team behind the project. Actually, we know each other. Many of us know each other for 10 or more years. Best friends from university, best friends from army. And let me tell you a little bit about the reception that the website got. And this blew our mind because when we launched it, we weren't sure if anybody is going to use it except for us. But in 3 months, we've had over 400,000 visitors, lots of Twitter followers, and this is with a zero marketing budget. Basically, people share it with each other after they find it useful. And if that weren't the case, we would simply die out because, again, we don't have a marketing budget. Average sessions of 9 minutes, which is, I think, crazy. It actually shows real engagement. And we're getting like hundreds of there's no other word for it than love letters, because people are really, really happy. And I'm not used to seeing the internet like this. The internet is usually a cold, bitter place that likes to complain. But in the case of Connected Papers, we only get sort of good mail, and even people who have criticism or feedback, they always wrap it and thank yous. So this is really encouraging for us, and gives us motivation to continue working on this tool, which, by the way, which I guess is clear that we're doing for free and in our spare time. Yes. Okay. So here's my theory, or here's our explanations for why Connected Papers is actually catching on. So the first is that we think it's the first actual useful tool to visually navigate paper space. Until now, you had to work with lists, you had to work with, like, as I said before, archive and RSS and crawling references. And now you get this fun way and visual way to move around, and it's very different. And it also gives you different results, like it covers the space differently. The second is that we have a surprisingly successful and universal algorithm. One thing that we're not using here in this project at this stage is machine learning models to like NLP models to set similarity between papers. And in actually, like, 2 of the team are deep learning engineers. So how can that be? And the reason is that this citation-based algorithm, we feel, is much more robust. It's working in every scientific field. I mean, people are using Connected Papers in economics and philosophy, in marine biology, in art of various kinds. And the algorithm works in all of these domains. And it also works across time. So for new papers, for old papers, we just always see sort of relevant results. The next reason is that we think researchers are basically a starved user base who are used to very ugly tools, not useful tools. And if you think about the most maybe popular tool right now, which is Google Scholar, it still looks like Google did in 2004 when it was launched. And there is a lot of room with this user base to innovate and to give solutions which helps them. Next reason is that there is a clear and immediate benefit. So a lot of the Twitter posts that we're seeing is basically someone who got into the website for 5 minutes, said, oh, wow, I searched for myself. Usually what people do first is they search for their own purpose. They're Googling themselves. And then they say, wow, there's a list of papers here that is super useful. either I am very knowledgeable of this topic and I know that these papers are good, or sometimes people are writing, I actually found new papers that I didn't know about that are relevant to me. And so they're immediately sharing. Yeah. And now I'll show you something that we haven't actually shown anybody before. And that is some historical snapshots of the website. I hope it's interesting to see how the sausage was made. So this was the first graph that we ever created. And this was still when we tried to actually map the entire paper space, universe, into our similarity metric. And this is not useful at all. And it went on to experiments like this and this. And maybe one interesting thing to say is that in the beginning, it used to take us over 1 hour to generate one graph. You would give an input, and then our computer had to crunch for an entire hour. And a lot of work actually went into optimizing it. So today it's either instant, if the paper has already been searched before, or takes about 30 seconds if it's a new search. And as people, of course, as people are mapping out paper space, more and more papers are instantaneous. And this is the first version, which was in Python, and we actually built the interface in Python as well. And finally, you have what we have today. So we actually did a lot of internal analysis, and we realized, or at least we believe, that this sort of tool, if we released it, if it would take 1 hour, nobody would use it. So it was worth to us at some point, when we saw that we ourselves were finding value from this, to work a little harder, to put in a few more months and release something that looks good and works fast. And finally, this is something new. Just last month, we had a collaboration for the first time with a conference, and we created for EMNLP, which is an NLP conference, we created a special graph that they put in their conference pages. And the papers that are in this graph are only from the conference. So hopefully we'll have a lot more collaborations like this in the future. Okay, maybe here we can have some questions, some Q&A, and then I'll continue to the final part. So how will I see it?
So anyway, we have a few questions in chat.
Just a second, I'm opening it.
So, for example, Igor asked, what sources do you use to build graphs? How do you deal with papers that are under paywall?
Okay, so that's a good question. And we are actually, our data partners are Semantic Scholar, which I talked about before. So every paper in their corpus, which is today, I think, over 180 million papers, is included in our database as well. And we don't really care if the paper is behind paywall or not, because we only give you a link to it. So we analyze the citations, and we build you a graph, and then we give you a link either to the PDF if it's available, or to the publisher page if it's under a paywall. And from there, you're sort of on your own. There is websites that help you get papers that are behind paywall, but I will not mention them now. And yeah, that's it. So Semantic Scholar is a huge database. It recently merged with Microsoft Academic Graph, which is also a project which collects, papers. Kostya, want to choose more questions for me, or?
Yeah, so the question regarding how much back is it going, does it show very old papers?
So the answer is yes. We have papers here from like 1900. Basically, as early as Semantic Scholar have parsed journals, that's what we have. There's no limitation on our side for the age. Let's do a couple more questions.
Do you give some kind of weights on the older the paper, the lower is the weight of it, or not?
Can you say again?
Do you assign some weights on the nodes in the graph according to the year of the publish?
No, not really. The date does not really influence the location and the weights in the graph. There's other things, but it's a complicated algorithm. There is a simple way to understand it, which is the similarity equals overlap of citations and references. And that's enough, I think, to understand how the positions and weightings are generated. Somebody asked here my opinion on archive sanity. Okay, I'm starting now to catch up with the questions. So Archive Sanity is a wonderful project by Andrei Karpathy, which is famous. Today he's director of autonomous driving at Tesla. Before that, I think he was more famous even for creating maybe the best course for deep learning by Stanford. And in his spare time, he created Archive Sanity. Now, I'll need to explain a little bit. It's basically dealing with the same problems that I described. But the thing is, Karpathy didn't really have a lot of time to work on it. And the website simply looks outdated. It never caught on. It's not maintained. It's not updated. And even though he open sourced it, it hasn't really been turned into something like people didn't invest a lot of effort into it. But the ideas, I think, were wonderful. And he also was a person who worked a lot with papers and really, I think, suffered from the same pains that all of us are suffering. Yeah, I think I'll share the presentation, definitely. I'm answering questions like, can we have the presentation? Okay, I think that's it for now. If you have more questions, then write them or you can ask them at the end. So let's move to the final part. So now in this part, I want to spark a conversation or ignite your imagination with a vision that I've had for many years. And I started when I talked about myself at the beginning. I said that this was actually the original idea that we had before Connected Papers. Connected Papers is just one feature from this idea. And the question is, can we have a social platform for papers? And let me explain what I mean. So for movies, there is IMDb. For books, there is Goodreads. For shopping, there is Amazon, where I can go and see many, social reviews, social proof that this is good, that this product has been tested and what people think about it. And there is a lot of value in the knowledge of the masses. Why don't we have the same thing for papers? Why don't we have a place where I can save my papers in the library like I do in a reference manager today, and give them reviews or write summaries about them, or ask questions that somebody else can answer, or maybe even the author can answer? Why don't we have all of these things that other domains have? Like in programming, there is Stack Overflow, where people ask and answer questions. Why don't we have that with papers? What we do have is very fragmented conversations in the web. Some people are writing in Reddit, other people in Twitter, others are writing blog posts. And whenever you start to tackle a new paper, you first need to hunt down all of these conversations, which, by the way, are not cross-pollinating. They're not talking to each other on different platforms. So how wonderful would it be if we could have one default place for all of this, where you would go to have this deep scientific conversation? And I try to list the benefits of it in the same mental model that I presented in the first part. And when you think about discovery, suddenly you can discover papers by their rating, or by the reviews, or even by simply the number of readers, the number of people that have this in their library. Today, you don't have the signal. We could have community lists, like they do, like there are for movies or for books. You could have similar libraries. For example, imagine there is someone else in the world who has a very similar library of papers to you. That's a great engine for recommendations. Look at that paper that they really like that you may also like. For skimming, definitely in the 5 minutes I have to decide if a paper is worth my time or not, I would definitely look at reviews that people have written and at the ratings and so on. And for reading itself, imagine if I had a section where I could ask questions and get some answers from the community. And people could write summaries of papers. By the way, already today, people are writing summaries, just they don't know where to put it. So people are putting their summaries in GitHub. They're putting summaries actually in Facebook groups. So in Israeli machine learning Facebook group, almost every week, or maybe sometimes every few days, somebody posts a summary of a paper, and then it's gone because nobody can keep up with summaries in some posts 2 weeks ago on Facebook. And for the owning part, then you can have this deep community discussion and analysis of papers, which today is just, you don't have it. You can only have it maybe in small social groups. And finally, you can even suggest improvements for papers. And suddenly this platform becomes the place where science is being done, not just being consumed. And my theory is that for such a platform to exist, you basically need 3 main pillars. You need to combine 3 things. The first one is a global database with all of the metadata and the supplementary material, something like Semantic Scholar or Google Scholar. And the second thing is strong library and reference management. So imagine that place is also where you collect your papers. And the third thing you need is an active community that produces content. And basically, I think I described Goodreads. What Goodreads is for books, I just described it for papers. And by the way, when maybe the slides should have been reversed, but when you think of the implications of such a platform, then I want to note a few things. First is that it's the first time that we can empower readers. So even in this meetup today, when we did the poll, what did we see? We saw that there's a vast majority that is reading papers and maybe even writing summaries for papers. And there is a minority who is also publishing papers. And the thing is that today, the signal of the readers, the reviews of the readers are simply not lost, right? When you try to find a paper, the main metric that you're looking at is the citation count. And the citation count only gets signals from people who write papers themselves, not from, like, for every one person who cited a paper, there's probably 1,000 people who read that paper, and their signal is lost today. Yeah, the second point I already talked about. And the third point I think is interesting. I'll tell it with a small story. So there was this paper, I don't want to name it, a few years ago, that was published in CVPR, and it was accepted, and it claimed state-of-the-art results. And a few months later, after they released the code on GitHub, there was this thread on Reddit where somebody said, listen, I sort of got into the code, and I think they had a bug with their evaluation metrics. And indeed, they did have a bug, and the state-of-the-art results were not correct. Now, the reviewers are not going through the code when they are reviewing the paper. So the paper was accepted, even though there was an obvious mistake. In that specific case, the authors were very, gracious people, and they immediately wrote in Reddit that they apologize for the mistake and that they'll rectify it. And the paper was sort of, in retrospect, removed from CVPR acceptance. But the damage has already been done in that many people in that conference and after the conference learned from that paper and got their conclusions from that. And I think the more accountability we have to the community and not just to reviewers, the better papers are going to be. Maybe if you know that people are going to comment on your paper and rate your paper and review your paper, maybe you will not only care about getting accepted to the conference, you will also care about actually being useful and being clear and being right. Now, I also want to discuss the challenges that I see for this kind of platform. The first and biggest one and most important one is that a community like this needs bootstrapping. Nobody wants to be or at least very little people want to be the first person to write a review or to write a summary in a dead website. So if we build this website tomorrow and it's empty and there is no information there and nobody's writing anything, would you want to be the first one to invest their energy? So the bootstrapping problem is real here. The second problem is community moderation. Suddenly, you can have a lot of spam. You can have hacking. You can have bots. These are problems. And the third thing is maintaining science integrity. And when you think about this, when we opened ourselves for social networks, there was a lot of useful things that we got from that, but also a lot of social problems. And the same dangers will exist with any platform that is social. So for example, will people start turning science into popularity contest? Will you call all of your friends to upvote your paper and downvote the opponent's paper? Will people like sort of lie about other papers? There's problems that are going to arise. And maybe even without thinking about malicious intent, here's a question. How do you rate a paper? Do you give it 5 stars or 4 stars? Is that a good way to rate a paper? Do you divide it to categories and you say, give me a ranking for clarity, give me a ranking for innovation and a ranking for something else? It's not a clear answer. And whatever you do, it will never be, exactly the ground truth of what good papers are, because there is no ground truth. Everybody's looking for something different. So these are problems. And for the last 2 points, for the last 2 bullets, I just want to say, whatever the problem, whatever the new problem is, our situation will definitely be better than what it is today, than having absolutely no signal, than having no information. I would take, something like good papers every day, even though sometimes it recommends the wrong, Goodreads every day. Even though sometimes it doesn't recommend me good books, even though sometimes it's wrong, it's hugely helpful. And for the first problem of bootstrapping a community, so I think I already hinted about what can be done here before. So one thing is that there already is a lot of user input about papers all over the internet. Some people have repositories in GitHub where they are writing reviews and summaries for papers in Markdown. Other people are posting on Facebook. Others are posting articles in Medium, and so on and so on. And I don't even know. I think that's the majority of summaries is actually unpublished. It's summaries that people are writing to themselves in their notebooks. Maybe a question I should have added to the poll today was, how many of you have written summaries and how many of you have shared them with your friends? So I think there's already a ton of information out there and we just need to aggregate it to start. And the other thing to do is what sort of I'm doing right now, which is to start, aligning the community towards a certain idea, towards a certain goal, which will be helpful to all of us. And I haven't talked about this, but of course, such a platform needs to be, we need to think who is controlling it and how. I wouldn't want this platform to be in the hands of one of the tech giants, for example. I would want maybe someone like Semantic Scholar to own it, because they are a nonprofit organization funded by Allen Institute for Artificial Intelligence. So like there are several different models, but it's something to think about. I think this is the final slide about this idea. So just to keep igniting the imagination of what is possible with such a platform, I said general things like improve science, which is obvious, but I think even things like funding research. Imagine a sort of a Kickstarter for research. Today, the process of funding research is horrible for many researchers. Imagine if you could have a page on the web where you sort of suggest your next research and people could back it. It could be a home for peer review. So I introduced Open Review earlier as one of the tools. I think it would be a wonderful integration into such a platform. And finally, Today, we're all still thinking about papers. Unfortunately, in 2020, papers are still PDFs for some reason. Why are they still PDFs? Is that the best medium to give this quanta of information? It's pretty obvious to me that papers in the future are going to be living, breathing projects on the web. Already many papers today are accompanied by a project page. And this platform could be a default home for such project pages, which will replace PDF. Okay, so this was all just to spark your brains. And I will end with this slide, which sort of summarizes everything that we've talked about in this meetup. There was part 1 where it was how to work with papers 101, where I introduced this mental model and showed you some tools. Part 2, where I gave you a demo of connected papers. And part 3, in which we talked about what the future could look like with a social platform, which is just one direction, but the one I wanted to talk about today. So that's it. Thank you, everybody. And now let's talk. I'm not sure if the right way to do this is with questions and chat or people actually talking. So Kostya, maybe you can suggest the right way. I will ask everybody if you can spare a few moments after the lecture to give feedback. There is a link here to a form. I'll also post it in chat in a second, and in the meetup comments. It will really help me improve for the next lectures. So thank you. And Kostya, what do you say? By the way, I think Kostya, you had an announcement first, right?
No, I think that first let's discuss. I'll do an announcement about our new community course on advanced STEM series at the end of the meetup. I suggest that you address a couple of questions that we have in chat first.
Just a second. First of all, I'm putting the link for the feedback form.
Yeah, sure. And guys, once Eddie responds on a few questions from the chat, I suggest that you just unmute and press your opinion or ask questions or invite any discussion around this topic.
Okay, so someone says, Guy Baruch says there is a ResearchGate social network for authors. And that's definitely right. But are you on it? Are you on it, and are your friends on it? And did you ever write in it? From what I can see, especially in my fields, it's silent. And I think they didn't implement 2 of the pillars that I talked about, or at least one of them, which was having a great reference manager, bootstrapping a community, and having a global database. So not just like what you have in a reference manager where everyone can upload a PDF and that creates an entry, but you need to have a global entry for the paper, which everybody writes their thoughts on, in the same link and not in different versions of the paper. By the way, Alex, my partner for Connected Papers, is here as well. So if you see a question that you want to answer, feel free to hop in.
There was a question before about old papers that I wanted to note on. It's actually an interesting result of the algorithm that if you are looking, for example, for a paper from, say, 1980, okay, and the algorithm will find papers that are connected to it. They will be mostly from the same generation. They will be more or less from the same time period because they are commonly cited and they have the same references as other papers in the same period. And in the derivative works, you'll see newer papers. And in the previous work, you will see older papers. So if it's a question we get often. I tried some paper and I got only results from up to 2000. How can I find newer papers? So what you need to do is you need to go to derivative works, find there a paper which is newer, which is related to what you are looking for, and then run this graph. And now you are thinking with portals, and you are advancing through time using our system.
Okay, I see someone wrote here, these points seem most relevant to data science related papers, but less to other academic fields. I guess some of the points are more related to data science, and I said today will be more biased towards data science and machine learning. But connected papers, for example, was embraced not just by the data science community. Actually, most of our users are outside of it. And I think the social platform as well should be similarly useful to people in medicine and every other science. Maybe some of the points that are related to code will be less true, but they also, like every science, needs an evolution of how the peer review process looks like, the funding process looks like, and of course the process of finding your next good paper. New question here. Did you consider calculating similarity?
Yes, this is the second most common feedback after we implemented exporting to a bib list.
Wait, let's repeat the question first.
Yeah, so the question is, did we consider calculating a graph for a list of papers, not for a single paper? And this is a very common feedback. We get it a lot. It's actually an interesting question. It's algorithmic and an interesting question. For a single paper, we can find the space around it in paper space. But now if I have, let's say, 3 papers, and I need to find the papers that are connected to all of them, I don't really have a way to do this because I don't have an embedding in paper space. I can only go with a radius around each one of them until I find something in common. And this radius can be very big before I find something relevant because it's a high dimensional graph. And it becomes more and more heavy computationally to enlarge this radius because the more paper you have, now when you look for further papers, the periphery is even bigger. So we are considering it, but at the moment it's complicated.
So someone asks, isn't an entry per paper in Wikipedia solve the social idea? So again, if I think about the 3 pillars that I think are required for the social idea, it's lacking the strong reference management and the strong metadata. And who will collect this? I mean, who do you expect people to actually edit by hand all the entries? I think what it needs to look like is more like if Semantic Scholar would add a social component, or if one of the reference managers became with a global database and added a social component. And of course, all of them have to get the goodwill of the community and bootstrap actual content. I'm not sure. In search and recommendations, there is a notion of diversity of results. How do you treat this? I'm not sure how to answer. Alex, you have an idea? We didn't really think about it. Diversity sort of, what we're presenting is what the, is reality. We're not, we don't have special cases. We're showing you the 40 most similar papers, or 40 or so most similar papers according to our metric, and they can be as diverse as paper spaces. Okay, I think the questions are slowing down.
Can I ask a question?
Yeah, definitely.
Okay, so be a human being. So my question is, from what I understood, this platform is about like if someone is getting to know in your field, so he can use it to understand like this field, right? So can we develop this algorithm to be like to use more the wisdom of experts? For example, like if I have this and I'm already like 2 or 3 years in a field, so can I like I don't know, add my own papers to this graph, and then someone else who is new in the field can like see my graph or use my knowledge in my graph, his graph, like Netflix does, like use the wisdom of the masses. This is what I'm asking.
Mm-hmm. So I heard about like 85%. I'm sorry, there was some kind of buzz in the background, but here's what I understood. You're asking, is there a way to input the wisdom of the masses by letting people sort of edit the graphs themselves, by adding papers that they think are relevant and so on, right? So looking at the future, one thing that we think about doing is adding user accounts, and then people can save graphs and they can save papers and save searches that they had. And the more we know about the sort of paper, and of course they can, they will be able to add things to their favorites and so on, and maybe have a sort of library. And the more we learn about them, the more we can present, you know, customized information. But this is all far future ideas. About people influencing each other, like other people, that's of course possible, but it's not something that we're considering at this point. It's like too many steps away, given the tool that we've built. And I remind you, this is still a side project at this point for us. Yeah, does that answer your question?
Yes, thank you. I changed also. Yeah, and it's a really cool tool. Thank you for letting us know about it.
Thank you.
I have one more question. So what are the other similar tools? Are there like connected papers, like on top of ResearchGate, and why? What are the other reasons they failed, and how did you learn on it? If you learned anything from their failures.
Mm-hmm. Okay, so similar tools. I think connected papers itself is unique. I haven't seen a tool like this. And I wish we did. If we did, we wouldn't have made it. So there are visual tools. One tool, if I even, maybe I can even share. I'll share a screen for a second. Screen one. Can you see connected papers again? Okay, so one of our example graphs is actually science mapping software tools, review, analysis, and so basically, if you open this example graph, every node here is a paper that talked about mapping science in some way or other. And maybe one of them, maybe I can find it with a search. Yes. So for example, VOS Viewer, which is here from 2009, is a software which shows you a citation graph, not a similarity graph like us, a citation graph. It basically means that the nodes are connected if they are citing each other. Okay, in our case, you can have papers citing each other and they will not, one of them will not even appear in the graph. So there is one example of a visual presentation of some aspect of paper space, but it was just, at least for me, it was never useful. I mean, it seemed like a gimmick. It was cool. It was nice to know that it existed, but I never actually searched with it, and I never found something useful with it. And I think the difference with connected papers is that we went through a lot of effort and a lot of iterations to actually make this useful in terms of finding new papers. So I don't know of any visual tool that is also, you know, effective. And if you do know of one, please send it to us. Now, there are other tools which are, especially in the last year or so, are starting to come out, which are also trying to present paper space, but not in a visual way, with lists. I think one of them is called Scite, SCITE, but it's too early to tell which is like really useful and which will catch on. There's one called Research Rabbit, I think, but I haven't been able to get into the beta. the reason that we created connected papers is that we had this pain for many years. So if we knew of something that solves it, we would have used it. Does that answer?
Yeah, sounds cool. Thank you.
More questions? Okay, Kostya, I think over to you. Everybody who came to listen and participate, thank you so much. This was great fun for me. I hope it was for you too.
Yeah, I would, before wrapping up, I would probably ask if somebody wants to share some kind of best practices for him or for her in working with papers, or some cool tools that were not mentioned during this talk. I believe we have here a lot of people that have a lot of experience with working with papers, so probably somebody. Okay, if not, then the last part of it, just 2 or 3 minutes, I'll do announcement about our new community course. It's kind of a bonus for everybody who made it until the end of this meetup. Eddie, can you stop sharing? So I'll share my screen. Just a moment. Okay. Okay, so earlier this year, in May, we launched our first community course on adversarial learning. It was part of Y Data, but we decided to open it for the community. So many people joined it, and I think it was a great success based on the feedback that we received. So back then in the summer, I posted a survey also in this meetup group and also in Facebook machine and deep learning community about what is the next course, advanced course in machine learning that people want to see from Y Data. And many people voted, and there were a couple of courses that gained a lot of majority of the votes. One of them was advanced time series. Another one was a machine learning in production. And as I promised, end of this year, we announced the first iteration of one of these courses, advanced time series. It will start in a month. End of January. First lecture will be on 25th of January. And I'll just talk a couple of minutes about this course. Its format is 6 weeks, 1 weekly lecture of 3 hours. It will be obviously online. Our lecture from Y Data, actually one of our most experienced lecturers, Gleb Ivashkevich from Moscow, have been preparing this course. It's totally free, and next week we'll send application form here in Meetup, and we'll post it in different groups. Its level is intermediate advanced level, so it's not for people that just started their first steps in data science, but people that already have some experience, a couple of years in research or in data science positions. It will be a lecture. Some of the lecture will include live coding sessions, and we'll have around 3 to 5 homeworks. The prerequisite for this course is Python stack for data science. So you have to be have some level of proficiency with NumPy, Pandas, and other Python libraries for data science, and foundations of deep learning. So some knowledge in architecture of CNN and RNN is required. In terms of what is this course about, it's mostly dedicated to deep learning techniques in time series modeling, something that is not very easy to find online today. But this field is developing very quickly last years. Just I think during last 2 months, Facebook updated their Prophet library for time series analysis, and I think Google released something to open source. So we work do more seminar research papers, review several data sets and different known use cases. So it's will be some balance between their academic lecture and seminar with use cases. Syllabus, there will be a lecture about intro to time series, overview, typical tasks. I think we'll try to cover basics of time series just to be on the same page with everybody, ARIMA models and so on. Then we'll go into regression problems with time series, RNN, attention mechanism, autoregressive neural networks, classification problems with time series, some use cases and CNN for that, segmentation tasks, time to event prediction and predictive maintenance. That's one of the fields that Gleb is a real professional in this field with many years of experience, specifically in predictive maintenance. And then we'll talk about representation learning for time series. I think that most of you heard about this field. It's not an easy one, and it will be one of the most advanced topics of this course. So next week we'll post application form, and you are all welcome to join us in this course. If you have any questions about this course, please ask. Okay, if not, then let me say thank you, Eddie, for joining us today. Great lecture, great tool.
My pleasure.
With you know, with spreading this tool into the masses, and more people will use it. And hope to see you again at Wide Data Meetups.
Bye, everybody. Thank you.
Thank you.